general relativity, step by step. Last time I differentiated a tensor with two contravariant indices, and now I'm going to give you the well, I'm not going to give you the absolute general case because it's a bit of a mess. I'm just going to give you a vector t, I, j, and one downstairs element k with respect to, let's say, L. Well, that's going to be t, di t, I, j, k downstairs with respect to di x, L. Now, we've got 1, 2, 3 indices, so we're going to have 3 correction terms. 2 of them are upstairs, so we've got 2 pluses. And I'm going to put my t there. I'm going to write dots here for what I've got to fill in, dot, 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 plus another one, dot, 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 t, dot, 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 minus the correction for this index here, k. It's the same shape, it's just got a different arrangement of indices, blah, blah, blah. Right, let's fill this stuff in. What we're going to do is, we've got I, J, K, L, we've got M and N for contraction. Okay, let's have a think about this. I, J, K, L. I'm going to contract on the 2 indices. I'm going to use M, the first and the second. What's left in that slot? Well, it's IJ, and here, so it's going to be MJ, and that's going to be an IM. So we've made a start there. Where do the other indices go? We've got an L which has got to be downstairs. Oh, sorry, the K index is attached to the T, so that must be downstairs there and there. And what have I got left? I've got to contract that M with something. That's going to be there. I may as well write it in the second place. What I'm trying to say is, rather than gamma of M and then something, it's going to be something and then M, because I want that M there in the second place to match that second place there. And that first place here, M, wants to match this first place here. And what have I got left? I've got an I here. That must be a J. And on the bottom I've got K, which has appeared there, so I've got an L here and an L there. I think that's right. I think that's right. The M's free. We've got 3 upstairs and 3 downstairs. I want 2 upstairs and 2 downstairs. One goes there, one goes there. There's not really any. I guess I could theoretically contract here, but that's the other index. Okay, so what have I got left? We are now looking at this K and L downstairs. So my summation is going to be on there and there. What's left? I and J are free. They must be there and there. And K and L must be there and there. Let's go through the whole of that. What we've got here is we want to differentiate, covariantly differentiate this complicated third rank tensor, and we'll have to do this when we start fooling around with the field equations. We've got to do this. We're going to differentiate a third rank tensor, 2 contravariant and 1 covariant indices with respect to index L. We've got curly d by dl, di by dl, ijk, and then the correction terms because the basis vectors themselves are changing. So we've got 2 upstairs indices, which are 2 positive corrections, and 1 downstairs, which is a negative correction. And I filled them in. You heard me talk about how to fill them in. I filled them in the only logical way possible. But we'll see. Well, just have a look at the expression for, well, here it is, v of ij. Everything just works together. Everything just works as you expect it to work. The signs reflect whether the superscript, whether the index is a superscript or a subscript, and everything just works. Having said that, it's a bit of a nightmare doing this. This is a complicated and difficult expression. There's lots and lots of terms. Depending on what dimension you're working in, you've got a lot of work to do to evaluate this thing, to do any work with. So I'm going to leave it there.